Imagine you're looking at some huge log file. It's a mess. And what if you want to extract the IP addresses from this log? Sure, you can use paging or open it up in Vim and search, but there's an easier way, RegEx. With RegEx patterns and Grep, you can easily extract anything you want from text files. Let's use Grep and pass in this RegEx pattern and see what it looks like. Voila! Now we can see all the IP addresses. Heck, we can even pipe that into a text file and take a look. We can even extract every IP address and only show the unique ones. This is the power of regular expressions, or RegEx for short, and we're going to jump right into the basics of how you can use RegEx to increase your productivity. We'll also show you a real-world example of how to use it and make your job easier. Let's look at some fundamental RegEx concept. Now don't worry, we'll keep it short and sweet. First up is pattern matching. Think of RegEx patterns as a secret code that helps you find specific text within a sea of characters. It's like playing a game of Where's Waldo, but instead of looking for a guy in a striped shirt, you're searching for text that matches a particular pattern. Now let's talk about metacharacters. These special characters are the superheroes of RegEx. They have the power to match, group, and manipulate text in ways that ordinary characters can't. Some common metacharacters include the dot, for matching any single character, the caret, for matching the start of a line, and the $sign for matching the end of a line. Now, quantifiers are another essential part of RegEx. They allow you to specify how many times a character or group should be matched. It's like telling RegEx, hey, I want this pattern to appear exactly 3 times, or I want this pattern to appear at least once. Some of the common quantifiers include the asterisk for 0 or more occurrences, or the plus sign for 1 or more occurrences, and the question mark for 0 or 1 occurrence. Let's dive into a quick command line demonstration of pattern matching using RegEx. In this example, we'll use the grep command to search for specific patterns within a text file. Let's create a sample text file called fruits.txt with the following contents. Now here's how you match an exact word. We'll type in grep apple fruits.txt. This command will search for the exact word apple in the file and return the matching lines. Now here's how you match a pattern at the beginning of a line. We'll type in grep b fruits.txt. Now the caret metacharacter matches the start of a line. This command will return all lines that begin with the letter B. And as we can see, it works great. Now here's how you match a pattern at the end of a line. We'll type in grep $, fruits.txt. Now the $sign metacharacter matches the end of a line. This command will return all lines that end with the letter Y. Now here's how to match any single character. We'll type in grep c.e fruits.txt. Now the dot metacharacter matches any single character. This command will return lines that contain the pattern C, followed by any character, and then the letter E. Now here's how you match 0 or more occurrences. We'll type in grep ap asterisk le fruits.txt. The asterisk quantifier matches 0 or more occurrences of the preceding character. This command will return lines that contain the pattern A, followed by 0 or more P characters, and then LE. These are just a few examples of how you can use RegEx with the grep for pattern matching in Linux. Let's explore metacharacters further with another command line demonstration. This time we'll focus on some common metacharacters used in RegEx and see how they can be used with the grep command. Let's use the same fruits.txt file from the previous demonstration. Now let's dive into some metacharacter examples. Here's how you match any character within a set. So we'll type in grep with a quote and an opening bracket, AEIOU, closing bracket, and a quote, fruits.txt. The square brackets define a character set. This command will return lines that contain any vowel, A, E, I, O, or U. And there it is. Now here's how you match characters not within a set. So here we're going to do the same command, except we're going to put a caret before AEIOU. The caret inside square brackets negates the character set. This means the command will return lines that contain any character that is not in that character set, or not a vowel. And here it is. Here's how we can match one of several patterns. We'll type in grep apple /pipe blueberry fruits.txt. Now the vertical bar acts as an OR operator. This command will return lines that contain either apple or blueberry. And we put in the backslash there as an escape character. And here we can see apple, apple pie, and blueberry. Great. Now let's talk about escaping metacharacters. Now here we have grep and a backslash, which is an escape, and then a space and fruits.txt. The backslash is used to escape metacharacters, treating them as literal characters. Here we're adding a backslash and a space. This command will return lines that contain a space, such as apple pie. These examples demonstrate how metacharacters can be used to create more advanced and specific regex patterns. By combining metacharacters with literal characters and quantifiers, you can craft powerful patterns to match exactly what you're looking for. Metacharacters are like the secret weapons of regex. They allow you to create intricate patterns that can match, exclude, or group characters in ways that simple literal characters cannot. Mastering metacharacters will take your regex skills to the next level and make you a Linux administration superhero. Now, in this demo, we've added on to our fruit list and it's become more complex. Let's see how quantifiers can help us with this. Here's an updated fruits.txt file. Now, let's learn how to use quantifiers. Here's how we can match repeated characters. We'll type in grep r backslash bracket 2 backslash bracket fruits.txt. And this command will return lines that contain exactly 2 consecutive R characters. This command will return lines that contain between 1 and 3 A characters. And as we can see, here's a list of fruits that contain either 1 or 3 characters in a row. Now here's how we can match words ending with berry. We can type in grep berry $, fruits.txt. This command will return lines that end with the word berry. Now here's how we match words with repeated vowels. We'll do grep A-E-I-O-U, and then we'll put in the brackets too. So we're basically combining our first 2 commands here for fruits.txt. This command will return lines that contain 2 consecutive vowels. And here's our list. This example demonstrates how quantifiers can be used to match patterns with specific repetitions, ranges of occurrence, and combinations of characters. The updated fruits.txt file provides a more diverse set of words that highlight the power and flexibility of quantifiers and regex. Remember, the key to mastering regex is practice and experimentation. Don't hesitate to play around with different quantifiers and see how they interact with metacharacters and literal characters. The more you explore, the more comfortable you'll become with creating powerful regex patterns that can tackle a wide range of text processing challenges in your Linux administration work. Let's take a look at some real-world uses for regex. Imagine you're a Linux system administrator who needs to analyze the auth.log file to troubleshoot and gather information about logins into your system. Now here we'll type in cat var log auth.log. Yikes, that's a lot of data. Let's use regex and grep to make some sense of it. First, let's search for all lines containing the word session in the log file. We'll type in grep session var log auth.log. Now this command will return any line that mentions a session, allowing you to quickly identify potential issues. For example, this. Remember grep as gather relevant errors promptly. And that's a good way to remember the grep command, to quickly recall the purpose of using grep to find error messages in log files. Next, let's search for specific user activities, such as sudo commands that are executed by the user Jeremy. We'll type in grep sudo.jeremy var log auth.log. Now here, sudo Jeremy is the regex pattern to match. Sudo matches the literal string sudo. The dot asterisk matches any characters, except new line, between sudo and Jeremy. And then Jeremy matches the literal string Jeremy. This command will return all lines indicating sudo commands that are executed by the user Jeremy. Now think of the dot in the regex pattern as a wildcard. It matches any character between sudo and Jeremy, and it helps you identify all sudo commands executed by Jeremy. Finally, let's search for lines containing SSH login events. These examples demonstrate how grep and regex can be used to analyze the provided auth.log file, helping you quickly identify errors, user activities, and login events. By tailoring the regex patterns to match specific log entries, you can extract valuable information and troubleshoot issues more effectively. As you explore the auth.log file further, you can create more targeted regex patterns to find the information you need, making your Linux system administration tasks more streamlined and effective. We've explored the incredible power of regular expressions and how they can revolutionize your Linux system administration game. From matching specific patterns and extracting crucial information to analyzing complex log files and troubleshooting issues, regex is your ultimate ally. Through these demonstrations and real-world examples, you've seen firsthand how these building blocks can be combined to create sophisticated and targeted regex patterns. But the journey doesn't end here. Regex is a vast and ever-evolving world with endless possibilities for mastering and refining your skills. Check out our courses on KodeKloud.com, where you'll learn even more about regex and Linux system administration. Subscribe to our YouTube channel and you can be notified when we add new videos, because we're going to deep dive into regex here in the future. You can also join our community where you can ask questions, get help, or help out other Linux enthusiasts. I'll see you there. Thanks for watching.